Our last lesson about circles in this unit is going to be about circles in the coordinate plane. And we're going to learn how to look at a circle on the coordinate plane and be able to write its equation, and vice versa. We're going to be able to be given pieces of information about our circle and also write the equation of that circle. But before we do any of that, we're going to first use the distance formula and see what we recall about that, because you're going to see how the distance formula is related to the equation of a circle here in a second. So first, let's see what we can do. Now, we did learn about distance formula way back at the beginning of the school year, and we're going to apply that to these two coordinates right here. So remember, the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And if you recall, when we learned about distance formula, we talked about how that's related to the Pythagorean theorem. So you can kind of see how all of these different things are intertwined. So if I'm talking about x1, x2, y1, y2, those represent the x and y coordinates of my two points that I'm using. So x1, y1 is going to represent the x and y coordinate of one of my points, and x2, y2 is going to represent the x and y coordinates of my other point. It does not matter which order you label these in, as long as you stay consistent. So since A comes first, I'm just going to go ahead and label that x1, y1. And since D comes second, I'm going to label that x2, y2. I could have done it the other way. It doesn't matter. Now let me go substitute that in. Square root of x2 minus x1 squared. So my x2 value is -3 minus x1, which is 6. And then I'm going to square those, plus y2 minus y1 squared. So y2 is -2, y1 is -3. And now I'm just going to simplify that. So remember, you can simplify whatever's under the radical just using your calculator if you want. But you don't want to type the actual radical symbol in because we're in honors geometry, right? We want to make sure that our answers are fully accurate by leaving our answers in radical form and simplifying it if we have to. But we don't want to put rounded decimals unless either the question tells us to or it's a real world situation. So whenever I simplify what's under the radical, I'm left with 97, but then of course the square root symbol is still there. Now, I don't know if you know or not, but 97 is actually a prime number. And since it is a prime number, I cannot simplify that square root, which tells me that the distance between A and D is the square root of 97 units. Now, the reason that we did that is because actually the equation of a circle is based on the distance formula. Because think about what a circle is. What is the definition of a circle? The definition of a circle is that we have one point and all of the points on our circle are equidistant from that point. So if I can find the distance from that one point, called the center, to any point on the circle, that's going to give me the distance to all of the points because they are equidistant from one another. And so the equation of the circle with center h comma k and radius r is x minus h squared plus y minus k squared equals r squared, which, as you can see, looks very similar to the distance formula. And if you actually come look at this diagram over here, it shows you how the distance formula is used to derive the equation of a circle. Notice that they tell us over here that our center is h comma k. So if I look at my diagram, I can see that h comma k is my center, and any other point on my circle is labeled as x comma y. So if you look at that right over there, I find the distance between these 2 points, which is represented by r. There it is. They've just substituted into the distance formula, and then of course they square both sides. That's how I get r squared. Now, notice here we have r squared on the left, here we have r squared on the right. It doesn't matter if you have your r squared on the left or on the right because they are equivalent expressions. One thing I just want to make sure that everybody understands is that this h and this k represent the coordinate of the center. Okay, now let's apply that to some information that we're given. So it says write the equation of a circle. Write the equation of each circle. Circle J with center J, which is at 2, 2 and radius 4. So remember they tell us that center is at h, k. If I look back over here, they tell us that the center is at h, k. So I'm going to go ahead and I'm going to label 2, 2 as h, k. And I'm just going to go ahead and use 2 different colors just so it's easier to see where all of these variables or these coordinates are being plugged in or substituted into the equation. Of course, the radius is going to be labeled r. The formula is x minus h squared plus y minus k squared equals r squared. So notice that I am not given any x and y values, and that's because x and y represent my inputs and outputs after I've gotten the formula in. So I have x minus my h is 2 squared plus y minus my k is also 2 squared plus my r is, not plus, equals my r, which is 4 squared. Now, normally I would be on your case about using parentheses. Make sure you use parentheses. Make sure you use parentheses. But really, why do we need parentheses? To make sure that we are substituting values in properly, right? Whenever those values are positive, it actually does not affect us as much. So it's important to know, like, when do I really need parentheses and when do I not? And the reason that I didn't put parentheses here is because actually your r value is always going to be positive. Why is that? Well, because it's the distance from the center to any point on the circle. And since it's a distance, it must always be positive. So that actually helps me out. I actually don't have to worry about parentheses. I don't have to worry that my calculator is going to give me the wrong answer because I forgot my parentheses. So now all I have to do is simplify. There's nothing to do on the left-hand side. I'm just left with x minus 2 squared plus y minus 2 squared equals, I do have to simplify on the right. 4 squared is, of course, 16, and I am done. On number 2, I want you to pause this video and see if you can label your coordinates and the information that you're given properly. So remember, the center is h, k, and the radius is r. So now let's substitute. X minus h squared plus y minus k squared equals r squared. Notice how I'm writing the formula every time. You, of course, don't have to do that, but I always like to, just in case I make any errors. It actually really helps in preventing that. So I have x minus, my h value is 0, squared. Now you might be thinking, hey, why are you even writing minus 0, right? I know that x plus 0 or x minus 0 is always going to be x. That's great. You should know that. However, since we're just substituting into our formula, let's take it one step at a time, especially since these are our notes. Y minus, my k value is -3 squared. Notice how I have both, I have two minuses here, right? I have this and this. Notice that they're in different colors because they come from different locations. This one in black ink comes from the formula. This one in blue ink, the negative, comes from the k. Both of them are equally important. You must have both of them, otherwise you will not write the correct equation. Equals my r value, which is 8 squared. Now I can go in and simplify. I didn't have to do anything on the left on number 1, but I do have some simplification to do over here. X minus 0, like we talked about earlier, is just x squared, plus minus a negative, of course, becomes a positive. So I have y plus 3 squared equals 8 squared is 64. All right, number 3. Again, I'm writing the equation of each circle, and this time I'm writing an equation of circle K that passes through 6, 4 and has a center at K, which is at 1, negative 8. Notice this time they didn't give us all of the information that's used in our formula, right? If I want to use my formula, I need x minus h squared plus y minus k squared equals r squared. They gave me my center, which of course is h comma k here. However, like they've done on number 1 and 2, they did not give me my r. They did, however, give me this coordinate right here. So let's look at what's happening. What's happening is I've got some circle where the center is at 1, negative 8, and it passes through 6, 4. So somewhere over here, 6, 4, right? I have to write the equation of the circle that's created by that information. So it's like I have this circle here, okay? And I need to now go find the radius that creates that circle. And I can't do that. I can't write the equation of my circle until I have that radius. So like I was saying, J is just some random coordinate on my circle. Well, let me just label it as a random coordinate. I'm going to label this as x and y. Once I've got it labeled as x and y, I have x, h, y, and k, and I can solve for r. Because remember, the radius is just the distance between those 2 points. So we are going to just use that distance formula in relation to finding the radius. So I have x minus h squared. My x, of course, is 6. My h is 1 plus y minus k squared. My y value is 4. My k value is negative 8. Oops. Equals r squared, which of course I don't have r. Okay? Now we're going to go simplify what's on the left-hand side. When you simplify that, you can do it piece by piece or you can do it all at once. You will end up getting 169 equals r squared. And then, of course, to find the radius, I'm going to just take the square root of both sides, which is exactly what distance formula tells us to do. Square root of 169 is, of course, 13. Now, some of you might be thinking, hey, isn't r squared what we use in the formula? Why do you want to go solve for r when we're just going to have to use r squared later anyway? Sometimes you're going to be asked to find the radius, right? So it's important for you to know how to do that. So now we're just going to finish our problem up, but this time we no longer care about that additional coordinate. All we care about is the radius and the center. So now I have x minus 1 squared plus y minus negative 8 squared equals r, which is 13 squared. And now I can just go simplify. Remember, minus a negative becomes a positive, so my final answer is x minus 1 squared plus y plus 8 squared equals 169. And that's it. So you probably did this quite a bit back when you were first learning about lines and you used point slope form. It's very similar to that, but of course it's no longer slope. We're talking about centers and circles and things like that. So what I want you to do now is pause this video and see if you can do all of number 4 on your own. All right, let's check and make sure that you were able to find the radius correctly. So my coordinate, that's x comma y, is just 2 comma 3. My center is h comma k, which is 2 comma negative 1. I go substitute in and I solve for r, which leaves me with 4. And now I'm just going to finish up by putting it into my final answer, which is x minus 2 for my h squared plus y minus negative 1 for my k squared equals r, which of course is 4 that I just found, squared. And then I just have to simplify. X minus 2 squared plus y minus a negative becomes a positive, so plus 1 squared equals 16. Now, one thing I want to point out, notice that this right here in the formula is a plus when my coordinate is a negative. And in the formula, I have a minus when my coordinate is positive. And that's because the formula uses a minus sign, okay? So if you're ever asked to find the center given the equation, you'll know which one's supposed to be positive, which one's supposed to be negative based off of the sign. So kind of be critical in your thinking whenever you're trying to figure that out. Okay, so now at the very bottom, we're going to now practice graphing. And so it says if you are given the equation of a circle, you can graph the circle by making a table or identifying its center and its radius. Making a table means I choose different x values and then I find their y values. But of course, since I now understand the formula, which is x minus h squared plus y minus k squared equals r squared, I can recognize that, hey, this coordinate is my center, h comma k. The value that's being squared is my radius. So if I look on this or first example, I can see that nothing is being added or subtracted to x, nothing is being added or subtracted to y, which makes the center 0, 0. This is my h, this is my k. And it works like that because, of course, x minus 0 is where I get x, and y minus 0 is where I get y. But to find my radius, remember the formula is that this is r squared. So we know that r squared equals 16. When I take the square root of both sides, that's how I get my radius, which is just 4. So I plot a point at 0, 0, that's my center. And then my radius is 4 units. So I'm just going to count up, left, right, and down 4 units. Radius there, that's 4, and that's 4. So notice this right here is all of these are equidistant. Okay? And now I'm just going to do my best to create a circle that connects all of those coordinates together. There's my circle. Again, any distance from the center to that circle is my radius, and that's going to be 4 units. We're going to do the same thing here. X minus h squared plus y minus k squared equals r squared. So I can see that x minus h, so that tells me that my h is 3. Y, notice over here, I have a minus in the formula, but a plus in the actual equation. So that tells me, hey, wait a second, that's because I had a minus and a negative next to each other. This is really y minus negative 4 squared. So now I can accommodate my negatives. Let me actually put it above. Y minus negative 4 squared. So now I can accommodate for my negatives. And so that tells me that my k value is actually negative 4, not positive 4. And then, of course, my r squared is 9. So my center is positive 3, negative 4. And my r squared is equal to 9 when I take the square root of both sides. That means that my radius is 3. So I'm going to plot the point 3, negative 4. And then my radius is 3. So I'm going to go in all four directions just because those are the easiest, and then I'm going to do my best to connect those. And again, notice that this distance from the center to any point on the circle is the radius. And that is it.